Today's lesson is on rational exponents. These are exponents that contain fractions, and this is log page 16 in your logbook. Rational exponents. A rational exponent is an exponent that can be written as a fraction. So if I have a base of a to an exponent of 1 over n, where the 1 is the numerator and the n is the denominator, then what's going to happen here, whenever I see this fractional exponent, is I'm going to always think of a radical. The base will become the radicand, the denominator will become the index, and the numerator will become the exponent. And this happens every single time. So let's look at some examples. For example 1, letter A, 4 to the 1/2 power. I see the fractional exponent, so I think radical. The base becomes the radicand, the denominator becomes the index, and since this is a 2, it's understood to be there. We don't have to write it. And the numerator becomes an understood 1 on the exponent position. So 4 to the 1/2 is the same as the square root of 4. Letter B, 8 to the 1/2. I see the fractional exponent, so I think radical. The base becomes the radicand, the denominator becomes the index, and the numerator becomes the exponent. So 8 to the 1/2 is the square root of 8. Letter C, negative 27 to the 1/3. I see a fractional exponent, so I immediately write down my radical. The base becomes the radicand, the denominator becomes the index. With a 3, I have to write it, and the numerator becomes the exponent, an understood 1. So negative 27 to the 1/3 power is the same as the cube root of negative 27. Letter D, 16 to the 1/3. I see the fractional exponent, so I immediately write down my radical. My base becomes the radicand, the denominator becomes the index, and the exponent comes from that numerator. So 16 to the 1/3 is the same as the cube root of 16. Notice these directions say write each expression in simplest radical terms. So I'm putting it in radical terms. Now these are the same 4 problems, except it says simplify. So if the problem says simplify, I don't want to leave the radical if I can simplify it. So now I must look to say, well, what is the square root of 4? Well, I know that that's 2. What is the square root of 8? Well, 8 is not one of my perfect squares, and I hope you're studying those from your warm-up number 6. So I'm going to have to factor my 8. Now, if you've been studying your warm-up number 6, then you will know that when you do 8 is 2 times 4, that 4 is a perfect square. So I could go ahead and say 4 times 2 is 8, and the square root of 4 is 2, and that leaves the 2 under the radical. So 2 square roots of 2. If you are still not sure what those perfect squares are, then you're going to have to go ahead and do your whole factor tree and get 3 2's under the radical right here. 3 2's under the radical, circle 2 of them, bring them out, that's your 4, and those 2 2's come out as 1 2 times the square root of 2. Letter C, the cube root of negative 27 is negative 3, and you should know that from your warm-up number 6 as well. And if you don't, you need to remember that whenever you take an odd root of a negative number, your answer is always going to be negative. And then you're going to come over here and do your 27 the same way that you did your 8 here. 27 is 3, which is prime, times 9. And 9 is 3 times 3. So there are 3 3's. And since this is negative 27, they have to be 3 negative 3's. The cube root of 16. Well, 16 is not one of my perfect cubes, but I know that 8 is, and 8 times 2 is 16, so I know that the cube root of 8 is 2, so this is 2 cube roots of 2. And if again you don't remember your perfect cubes from warm-up number 6, then you need to come over here and look at your 8 factored right here. You see you have 3 8s, so right here you'd have the cube root of 2 times 2 times 2, that's 8, times this 2, circling those 3 2's to come out as 1, times the cube root of 2. Now, rational exponents do not have to always have a numerator of 1. We learned these fractional exponents that we just went over in Math 1, and so that was a quick review. Now what we're going to do is expand it just a little bit more, and we're going to look at rational exponents that have a numerator of some number other than 1. Well, the thing is that we have the same idea going on here. If I have a to the m divided by n power, I still see a fractional exponent, so I'm still going to think radical. The base is still going to become my radicand. The denominator is still going to become my index, and the numerator is still going to become my exponent. Now the thing is, this exponent can go inside or it can go outside, and we're going to talk about that on the next slide. There are some noteworthy comments that you should know. Whenever you have an exponent that has a numerator other than 1, you need to always make sure that that exponent is in lowest terms. So you don't want 6 over 4. You would reduce that to 3 over 2. Your n has to be positive because your index must be positive. If this is a negative exponent, then that means that the numerator is negative, not the denominator. Order here doesn't matter. Okay? So let's look at this. A to the m divided by n could be the nth root of a to the m, or it could be the nth root of a raised to the m power. Okay, the order really doesn't matter. This way, what we're doing is we are raising to the power first. So we're going to do power first here, then take the root. This order, we're going to do root first, then raise to the power. So we take the root first and then raise to the power. Usually, taking the root first and raising to the power is simplest. This one is usually easier. Not always, but it is usually easier. Okay, let's look at a couple of examples. The first example is 4 to the 3/2 power. 4 to the 3/2 power. The first thing I'm going to do is rewrite this. It says simplify, so I'm going to rewrite this as a radical. The base is 4, so that becomes the radicand. The denominator is 2, so the index here is 2. And the numerator here is 3, so the exponent is 3, and I have to decide whether to put it inside or whether to put it outside. Well, I know what the square root of 4 is, so I'm going to take the square root of 4 first, and then I'm going to cube it. So the square root of 4 is 2, and then I cube 2, and that's 2 times 2 times 2, which is 8. So 4 to the 3/2 power is 8. Now let's look at letter B. Negative 8 to the 4/3 power. Well, this is the cube root of negative 8, and I'm going to raise that then to the 4th power. I know what the cube root of negative 8 is because that's one of my perfect cubes. That would be negative 2. And now I'm going to raise negative 2 to the 4th power. So that gives me negative 2 times negative 2 times negative 2 times negative 2. Well, negative 2 times negative 2 is positive 4. Negative 2 times negative 2 is positive 4. And 4 times 4 is 16. So negative 8 to the 4/3 power is negative 16. Now, All of your laws of exponents remain true for rational exponents. So let's look at a couple of other things that we can simplify. Letter A, 100 n to the fourth raised to the 1/2 power. Well, I know that that means the square root of 100 n to the fourth. And if I've been studying my perfect squares, I know that the square root of 100 is 10. And if I remember the pattern that we learned for in exponents on variables, we said the square root of n to the fourth is n squared, because 4 divided by 2 is 2. If you don't remember that, then you're going to have to do n times n times n times n, and knowing that we're pairing these up to get out of the radical, so 2 n's come out as 1, 2 n's come out as 1. And that's where the n squared came from. Okay, let's look at letter B. Letter B is the 9th root of x to the third. Well, now this one, I don't know what the 9th root of x to the third is, so I'm going to change this from radical form back into rational form. The x becomes the base, the 3 becomes the numerator, and the 9 becomes the denominator. Now I want to reduce or simplify this fraction, because under our noteworthy comments right back here, we said that the exponent must always be in lowest terms. So I can reduce 3/9 to 1/3. So this is the same as the cube root of x to the first power. When my problem starts out in radical form, I want to leave it in radical form. Okay, x to the 1/3 is also an acceptable answer, but usually if we start in radical form, we want to leave it in radical form. And our last example here is 49 to the 3/2 power. Well, I see that fractional exponent, so I'm going to write my radical down. I know it's a square root. I know that the radicand is 49, and I know now that I'm going to cube the square root of 49. The square root of 49 is 7, and 7 cubed is 7 times 7 times 7. 7 times 7 is 49, and 49 times 7 is 343. So 49 to the 3/2 power is 343. Well, now what you need to do is go back and look at this video again if you have any problems or questions, and then you can start on your homework. I hope y'all are having a good day.